Good afternoon, everyone. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, Apple Valley, California.
Science and Technology Channel.
That's right. The masters of none, the experts of none.
Absolutely. Just listen to a couple of our topics lately.
We're just the messenger. All right. Vision is one of the most important human senses, yet more than 300 million people, you heard that right, 300 million people around the world are at risk of losing it due to various retinal diseases. And we talked about what was that? Macronal retinal MACD.
Like
last month.
degeneration.
Right. Yeah, we talked about that just last month.
Right.
Although recent treatments have helped slow the progression of these conditions, no effective therapy has been able to restore vision that has already been lost until now. Researchers at Korea Advanced Institute of Science and Technology, KAIST, have developed a new drug that successfully restores vision.
This is amazing.
I'd like to know more. Would you like to know more?
Yeah, this is pretty amazing thing. So you think about all the optometrists right now that are probably maybe thinking, maybe I should think of a different, like a
Profession?
plan B for my profession, So anyway, on March 30, KAIST announced that a research team headed by Professor Jin-Woo Kim from the Department of Biological Sciences has created a new treatment that regenerates retinal nerves to restore vision. Yeah, in experiments using a disease model mouse, 11 mice, the team achieved both retinal regeneration and vision recovery by blocking the PROX1, which is short for Prospero homeobox 1 protein, which normally prevents retinal repair.
Why would we even have that? Something that prevents retinal repair.
Yeah, I don't know. The results were long-lasting, with effects continuing for more than 6 months. So that's pretty good.
Yeah. This study marks the first successful induction of long-term neural regeneration in mammalian retinas. Mammals, not reptiles.
That would include us,
or
right?
Insects. Yeah, that includes us. Offering new hope to patients with degenerative retinal diseases who previously had no treatment options. As the global population continues to age, the number of retinal disease patients is steadily increasing. However, no treatments exist to restore damaged retinas and vision. The primary reason for this is the mammalian retina's inability to regenerate once damaged.
Okay. So studies on cold-blooded animals such as fish, known for their robust retinal regeneration, have shown that retinal injuries trigger Muller-Glia cells to de-differentiate into retinal progenitor cells.
Wait.
Right? Is that right?
Yeah.
Am I good on
I don't
those?
think I understood it, though.
Yeah. Which then generate new neurons. However, in mammals, this process is impaired, leading to permanent retinal damage.
Oh, that's too sad. Through this study, the research team identified the PROX1 protein as a key inhibitor of Muller-Glia dedifferentiation in mammals. PROX1 is a protein found in neurons of the retina, hippocampus, and spinal cord, where it suppresses neural stem cell proliferation and promotes differentiation into neurons.
The researchers discovered that the PROX1 accumulates in damaged mouse retinal Muller-Glia, but it is absent in the highly regenerative Muller-Glia of fish. Furthermore, they demonstrated that the PROX1 found in Muller-Glia is not synthesized internally, but rather taken up from surrounding neurons, which fail to degrade and instead secrete the protein.
Yeah.
Okay.
Based on this finding, the team developed a method to restore Muller-Glia's regenerative ability by eliminating extracellular PROX1 before it reaches these cells. This approach involves using an antibody that binds to PROX1 developed by Celiaz, Inc., a biotech startup founded by Professor Jin-Woo Kim's research lab. A lot of these researchers, they do a startup based on something that they find, a breakthrough, and I think it's genius that, they carry the idea, through to manufacturing. It's pretty cool. When administered to disease model mouse retinas, this antibody significantly promoted neural regeneration. Additionally, when delivered the antibody gene to the retinas of retinitis pigmentosa. Do I have to do that with a wand?
No?
Retinitis pigmentosa disease model mice. It enabled sustained retinal regeneration and vision restoration for over 6 months.
The retinal regeneration therapy is currently being developed by Cilias Incorporated for application in various degenerative retinal diseases that currently lack effective treatments. The company aims to begin clinical trials by 2028.
Yeah, these clinicals, they take a long time. You got to go through different phases the FDA wants you to.
Right.
I guess for our safety. Dr. Yoon Jung Lee stated, quote, "We're about to complete the optimization of the PROX1 neutralizing antibody, which is CLZ-001, and move to preclinical studies before administering it to retinal disease patients. Our goal is to provide a solution for patients at risk of blindness who currently lack proper treatments." Love it.
Yeah, this is good for those people that are. I've been wearing glasses for over 50 years, 57 years, and the last probably 20 years, my prescription hasn't changed much. It's been very slight, which I'm grateful for. But I know people that don't fare so well in that department, and a lot of it has to do with all kinds of issues, right? Disease or illness or just genes, I guess, right?
Yeah.
Because it's funny because I have a son that does not wear glasses. Both my parents wore glasses. Both my wife's parents wore glasses, I believe. She wears glasses or contacts.
Yeah, I wonder how
I
that
wear
skips.
glasses. Yeah, one of my sons should wear glasses, but he doesn't very much. So I'm hoping that but both my son that doesn't wear glasses, both of his kids are now wearing glasses. They're 13 or almost 13. Yeah, 13 and no, he'll be 13 this year, and then one's 10. So yeah. I don't know. It's just weird how that just goes, right?
Should we donate your son to science so we can poke and prod and see
Well,
how
not
he's
yet.
Not yet?
Yeah, not yet. Maybe in a few years.
Okay.
But yeah, not yet.
Okay, we'll keep him.
Yeah, he's doing good. So
Okay.
yeah, we're gonna keep him around. Science doesn't need him for a while. So
all right, folks, thanks for joining us. We'll catch you in the morning.
take care, everyone. Thanks.